Today we're on page 3 of the Chapter 5 Chemistry 1 packet, and we're going to be talking about energy level diagrams. Now the interesting thing is there's a how to do it and a what it means video. This is the how to do it. Okay, I'm going to first show you how to do it. You're not really going to know what it means, but the how to do it, if you learn it first, it'll help you with the what it means later. So, the how to do it. First of all, we're going to look at sulfur and we're going to figure out how many electrons does sulfur have. So we look at the periodic table. We realize that the atomic number of sulfur is 16. So it has 16 protons, but it's also going to have 16 electrons as well because they're going to match. All right, so we have 16 electrons for sulfur. What we're going to do is we're going to fill them in this energy level diagram starting from the bottom. The way that we represent an electron is by little arrows. Okay, you can draw an arrow that faces up and an arrow that faces down. Okay, we're drawing half arrows just because it's easier. If that really bothers you and you really want to do a whole arrow, that's fine. Just a little extra writing. Okay, so every arrow is going to represent one electron. What we're going to do is we're going to fill in the electrons in these blanks. Okay, when you could put one electron facing up and one electron facing down in every blank. So you're going to start at the 1s, and then when you put 2 here, you're going to move up to the 2s, etc. So we'll start filling in 16 electrons. So we're going to go 1, 2. We always do an up and then a down. And then we're going to move up to the 2s, 3, 4. And then when we get to a set like this that have 3, we're going to put 1 up in the first one, 1 up in the second one, and 1 up in the third one. Okay, so you always put 1 in each blank before going back and putting a second one in this, and a second one in this, and a second one in that. So far we've done 10 electrons. We need to do 16 altogether. So that's 10. We're going to go 11, 12, and then we're going to go 13, 14, 15, 16. So this is what we would call the energy level diagram for sulfur. And you would have filled in these arrows accordingly using this chart. So you can reference this chart for the homework. You're going to look at this chart and you're going to basically copy down, 1s, the 2s, the 2p, the 3s, the 3p, and once you have filled in of 16 electrons, then you're done. You don't have to go into the next bunch. You just don't even draw those. Okay? Now, I'll show you an example on the homework in a minute. Let me just explain now what's called the electron configuration. The electron configuration is going to match the drawing, but you're writing it out in one big line. So let's look at the 1s. The 1s has 2 arrows, which represent 2 electrons. So that's 1s, 2. The way you write that is with an exponent. It looks like 1s squared, but it really just means 1s, 2. There are 2 electrons in the 1s. Then we move up to the 2s. This also has 2 electrons. So 2s2 would be this one right here. Then we're going to look at the 2p. There's 3 blanks. Every blank has 2 electrons, so that's 6, 2, 4, 6. So we're going to write 2p6 because there are 6 arrows in that. Then you go to the 3s. There are 2 of them there, so you're going to write 3s2. And then in a 3p, there are 4 electrons, so you're going to write 3p4. That's what we call the electron configuration. All right, there's something called the detailed configuration. Again, we're not really understanding yet what it means, but I'm just showing you the how to do it. When you have the p orbitals, they're called orbitals, we'll learn that soon. The first one is the x, the second one is the y, and the third one is the z. Just like in algebra you learned an x, y, z axis, 3 dimensions. So this is the x, this is the y, this is the z. So how many are in the x for the 2p? There are 2 arrows in that one. How many are in the y? 2. How many are in the z? 2. So you could write 2px, 2, 2py, 2, 2pz, 2, because each one has 2. Then if we look at the 3p, the x and the y and the z, you're going to notice that we have 2 in the first one in the x, 1 in the y, 1 in the z. So this would be 3px, 2, 3py, 1, 3pz, 1, and that's going to be right here. This is only for the detailed configuration if I ask you for the detailed, and I'm only going to ask you for detailed for the p orbitals. We're not going to move into the d's and the f's for that, but if you had the p's, it would be x, y, z. Okay, the homework is not going to have this tonight. Lastly, there's a shortcut. What you can do is look at the periodic table and look for the noble gas, the last column, before sulfur, and that's going to be neon. neon has 10 electrons. So what you can do, there's a shortcut for writing this electron configuration. We're not going to do this on the homework, but just for later. The shortcut is to just shortcut the first 10 electrons. So 2, 4, 6, 8, 10. So we're going to stop. We're going to call this all neon up to 2p because it has 10. And then we're going to move into what comes afterwards. So 3s and 3p. So 3s2, 3p4, that's what's past neon because neon has 10. So the shortcut would be neon in brackets and then 3s2, 3p4. But for the homework, we're just going to do the regular electron configuration for tonight. Now we're on page 4 of the Chapter 5 Chem 1 packet, and we're going to use what we learned on page 3 to do page 4. So you are going to have to reference page 3 to do this. Okay, so we're going to do carbon. Carbon, first of all, let's look for the electrons, and we look on the periodic table. Carbon has 6 electrons. So we need to draw 6 electrons in an energy level diagram. We'll start with the bottom, which is 1s. So we draw 1 blank for the 1s, and that's going to get 2 electrons. So we go up, down, because you can only put 2 electrons per blank. Now look at the diagram on page 3. That's your template, and you're going to see that 2s comes next, and so you're going to draw 2 more electrons in that one, and then 2p comes next. You draw that a little bit to the side and higher than 2s, and you have only 2 more electrons to draw because you need 6. So this is number 5 and this is number 6, and now you're done because you have 6 electrons all together. So that's called the energy level diagram, and now we're going to write the electron configuration. So you would write 1s, and how many are in that? 2. Then you're going to move on to the 2s. How many are in that? The answer is 2. And then the 2p, how many are in that? The answer is 2. And that's done. That's the electron configuration of carbon. So we have drawn the energy level diagram right here. We wrote the electron configuration right here, and they match. Okay, now we'll move on to copper. Copper is number 29. So a few more electrons on this one. 29 electrons. So we'll move this over, give ourselves some space, and we can use the template again on page 3. So we're going to start with 1s, and we're going to put 2 in there. 1, 2. Then we're going to draw 2s. We're going to put 2 in there. 1, 2. Then we go to 2p. We're going to do 6, and remember you go up, 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 down, down, down. So that's 10 altogether. We still got 19 more to go. So we're going to go to 3s. And then we go up, down. And then if you look at page 3, you'll see 3p comes next. And then you're going to go up, 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 down, down, down. And that brings us to 18 electrons. We still have a bunch to go. So look very carefully on page 3. You're going to see that 4s is lower than the 3d. Okay, so it's like you're climbing up a mountain, and you're trying to get footholds, or you're rock climbing. So you're going to go like here, then you're going to go here, then you're going to go there, then you're going to go there, then you're going to go here before you go to 3D, because 3D is up here. If you look at the diagram, you'll see it. That 3D is a little bit higher than the 4S. So you have to go to the 4S before the 3D. Okay, so 4S, you're going to go up, down. Then you're going to go to 3D, and you have, let's see how many more we have left. We did 29 altogether. We did 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we have 9 more to go. So remember what we do? We go up, 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 down, 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 and that's it. So if we write this electron configuration, it's going to go 1s. I'm just going to actually write all the orbitals first, and then I'll fill in all the numbers so I don't have to switch colors all the time. So this goes 3s, 3p, 4s, 3d. And there are 2 in the 1s, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d9. It corresponds to all the electrons. Now, unfortunately, as we know in life, there are exceptions. So here's the exception for copper. Copper is a big exception. It actually takes 1 out of the 4s and moves it to finish up the 3D. So instead of 4s2, 3d9, this actually goes 4s1, 3d10. Okay, there are going to be two exceptions that we're going to memorize. Copper is one, and chromium is the other. These are exceptions. They're actually listed on page 3 as well. Okay, so without going crazy, just understand copper is an exception. Now let's move on to the next one, which is Fe plus 3. Now we have something interesting going on here. We have a plus 3. Remember that plus 3 means you lost 3 electrons. So we're going to forget that for now, and we're going to just do the diagram first with regular iron. So regular iron would normally have 26 electrons. So let's just do 26 for now, and then we'll take away electrons when we're ready. So 26 electrons is regular iron. We're going to do our diagram. Again, look at page 3. After a while, you're going to get really used to this. So 1s, I'm going to draw this briefly, 1s, 2s, then 2p, then 3s, then 3p, then 4s, then 3d. Now I knew where to stop because I know what I'm doing here. You're learning, so you just draw a bunch and then see how much you need. Okay, we have 26. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then up, 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 13, 14, 15, 16, 17, 18, 19, 20. So I have 6 more to go. 21, 22, 23, 24, 25, 26. So there's my drawing so far. But what I have to remember is this is not iron, it's iron plus 3. So if you're a plus 3, that means you lost 3 electrons. So this is really going to go down to 23 electrons. So we're going to make this 23. Now, quick story to help you understand where we're going. Let's pretend that these are first graders, second graders, third graders, fourth graders. And they're lining up in size order. Okay, so here's a short first grader, second grader, short and taller, third grader, short, medium. But then we have this really short fourth grader and a really tall third grader. So this third grader is tall. This fourth grader is short. Maybe some of you can identify with this. I was on the short side. I was not on the tall side. So if they line up in order, size order, the fourth grader has to line up before the third grader. However, if all goes well, who's going to graduate first? The fourth grader. So the fourth grader graduates first, even though he's shorter than the third grader. So the point is this. When you lose electrons, it's kind of like graduation. Who's going to get lost first is the higher numbered electrons, the higher levels. So the 4s get lost before the 3s, even though the 3s have more energy. So you're going to cross off 3 electrons. Here they are. 1, 2, and then you have to cross off 3. So it's kind of like the elementary school kids got to go on a special field trip, and the fourth graders all got to go, and there was one extra spot. So they took 1 third grader with them, okay? But the fourth graders got priority because they were going to graduate. So therefore, the final answer for this is going to be 1s, then 2s, then 2p, then 3s, 3p. There's no 4s. Okay, I'm going to write it and then cross it off. And then there is a 3d. So if we fill in our electrons, it was 1s2, 2s2, 2p6, 3s2, 3p6. It was 4s2 and 3d6 originally, but then we crossed off the entire 4s because it got lost, and this turned into a 5 for the 3d. So this is the electron configuration for iron plus 3, and remember that you always lose electrons from the higher level before the lower level, even though the higher level started putting arrows in before the lower level. Again, this is the how to do it. If you don't totally understand what it means, that's fine. We're going to get to that. This is just the how to do it. Okay, lastly is iodide. So iodide is I minus, and that means it gained an electron. So iodine used to have 53 electrons. This is going to be a big one. 53 electrons. And then we're going to see what happens with this. Okay, let me separate this a little bit for us. And separate it over here as well, so we don't get confused. 53 electrons for I minus is going to be 54, but we're not ready yet. So let's do the diagram. We're going to go 1s, 2s, 2p, 3s, 3p. 4s first, then 3d. Then we're going to go to 4p. If you look at page 3, you'll see 4p comes next. Then you're going to look and see 5s comes next. And then you're going to have a 4d after that. And then after that, you're going to have a 5p. So here are all your orbitals, which we'll just call them the blanks, of course, because we don't know what orbitals are yet. And we're going to fill in our electrons. We have 53. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Oh, no. That should have been 30. Oh yeah, I forgot the 3s. Sorry about that. That's 30. Okay, keep going. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. Now we have to get to 53. So 49, 50, 51, 52, 53. So we're going to end there. But remember, when we're negative, that means we gained an electron. So instead of having 53 electrons, we're really going to have 54 electrons, and that last electron is going to go right there. Okay, so now we're going to write what's called the electron configuration for this. So I'm going to write it out. You write it out on your own. And, whoops, let's see if we can match up our answers. I'm just going to write the orbitals first and then fill in because I'm using colors here. So 1s, 2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4s2, oh man, 4p6, sorry, 4p6, 5s2, 4d10, and 5p6. I'm just going to fill in my little numbers here. I'm trying to color code it so you see that the red numbers are representing the arrows and the blues are representing the blanks, and you could see how it all matches up. And there's your final answer for I minus. So this will help you with how to do tonight's homework. You have 4 similar problems to do. You're allowed to use page 3 to help you out with the order, and you're just going to fill in the blanks in order like this, and then write out the electron configuration like this. When you lose electrons, remember to lose from the highest numbered blanks first. And when you have a minus sign, that means you add in an extra electron. And I'll just fix this part because this is actually part of that.